In this example, you're being asked to identify the nucleophile and its nucleophilic atom, as well as identifying the substrate and the leaving group of that substrate, as well as the electrophilic carbon atom of that substrate. So here we have two species. One is a substrate, one is going to be the nucleophile. Easiest way to find the substrate is to look for that leaving group. What is a good leaving group? So there's a lot of good leaving groups, things with resonance, halogens. Here we can see we have iodine, which means it could be the good leaving group, and it is. So let's draw this out a little bit differently, because if this is iodine, that means this is the substrate. So we've identified the leaving group, which is iodine, on the substrate. Now we need to identify that electrophilic carbon atom. I'm going to draw this molecule out just a little bit differently. I'm going to draw it in this expanded version, because that iodine is bonded to that carbon of that CH2 group. Okay, so I'm going to put that carbon in red here, and I'm going to put it in red here. That carbon, that red one, is the electrophilic carbon atom, because that iodine is pulling electron density away from it because it's more electronegative than carbon. That puts the partial positive charge on that red carbon. So that's where the nucleophile is going to attack. So we've identified all the components of the substrate. This species here is the nucleophile. And what do nucleophiles do? They donate electrons to the electrophile. So we need to look for a species on this nucleophile that has lone pair electrons, and that's the nitrogen in this case. That nitrogen has a lone pair of electrons. Those are the electrons that get donated to that electrophilic carbon atom. So this species on the right here is the nucleophile. The nitrogen atom is the nucleophilic atom.